Hi, so today we are talking about area and we're going to go through the basic area formulas. I'm going to be taking the notes on a worksheet that you may have received in class. If you didn't, you should be taking notes on lined paper. So to start, this paragraph up here talks about the terms base and height, and those are really important terms in this entire unit. Something that your teacher is going to focus on a lot is that the base and the height of a shape have to be perpendicular to each other. That's how you can find the base and the height. Perpendicular means to make a 90-degree angle. So we're just going to go through these shapes that are given and identify the base and the height. So in the first shape, we are very familiar with this shape. It's a 90-degree or right triangle. It's a right triangle, which means that if there is already a 90-degree angle, it means that the base and the height are just the two segments or sides of the triangle that make 90 degrees. So I'll call this the base and this the height. And these could be interchangeable. It doesn't matter. Alright, this next one looks like a square. It's a square because all the sides are congruent and we have a 90-degree angle. If we have a 90-degree angle, it means the base and the height are the two sides that make that 90-degree angle. Alright, over here, this looks like a trapezoid. Normally we see trapezoids that have this triangle shape on either end, but the definition of a trapezoid is just that they have two parallel bases. So we have two parallel bases. It doesn't really matter what my other sides look like. So this is a trapezoid. My base and my height are the two segments that make a 90-degree angle. So I'm going to label them here. This is my base and this is my height. And actually with a trapezoid is that this top base also makes 90 degrees. So we'll see it later in the video that a trapezoid has two bases. We could call this base 1 and this base 2. It has two bases and a height. The last shape, I do not see any 90-degree angles. When that happens, this looks like a parallelogram. When that happens, we have to draw in our own height. And the easiest place to draw our own height is over here to the right. And the reason that's helpful is because I can create a 90-degree angle when I do that, and then we will be able to find the height. So I'm going to label in this one that my base is this entire 30-millimeter line. My height is the line I just drew in, so that I had to draw my own height in that time. Alright, now we're just going to go through some practice. For each of these, we're going to just write the formula, and we are going to then do an example. The first one we'll do is a rectangle. Rectangles and squares are great because they already have 90-degree angles. We know that by definition. So it's very easy to identify the base and the height. The area formula is simply base times height. So for our example for a rectangle in this space, I'm going to draw a rectangle that has a 90-degree angle, and it has two congruent sides on either side. And then this time I'm going to give you that the diagonal is 13, and I'm going to give you that the base is 12. Now in this case I know my formula is area equals base times height. I do not have the base and height right now. I have the base of 12, I do not have the height, but you might recognize this is a triple. It's the 5, 12, 13 triple, so my missing side is 5, and in that case my area is just base times height, 12 times 5, which is 60. In this problem we don't have units, so I'm just going to write units squared. Alright, next are triangles. Here are two common types of triangles we'll see. The first one is if you are given that it's a right triangle, that is great news, because you already have that perpendicular base and height. So this is the base, this is the base, this is the height. Second triangle does not look like a right triangle, so I would have to draw in my height. So this would be my height, and this would be my base. The area formula triangle can be written two ways. It can be written 1/2 times base times height, or you could say area equals base times height divided by 2. Alright, so our example for a triangle is we are going to do how to find the area of an equilateral triangle. And I'm going to say the side is 10. So I'm going to draw an equilateral triangle. I know that has 60-degree sides, or 60-degree angles, and I know all of the sides are 10. Now notice there are no 90-degree angles, no perpendicular sides, so I have to find the height. So I'm going to draw in the height, make a 90-degree angle, and I have to use my 30, 60, 90 reference triangle. When I do that, here's my reference triangle I'm going to use. This is my 30, 60, 90. I know that this little piece right here is 5. That's across from the 30-degree angle. So the height would have to be 5 radical 3. And now I'm going to find the area. The area of this would be 1/2 times my base of 10 times 5 radical 3. And now we'll actually do this problem out. So let's see, I have 1/2 times 10, that's 5, times 5, that's 25, radical 3 units squared. Alright, now what I have written right here is that all of the following shapes can be dissected into rectangles and triangles. That means you can cut them up into rectangles and triangles. So if you forget a formula, just cut up the shape and take the formula, or use the formula for the pieces that you know and add them all together. But we are going to learn the formulas for these. The formula for parallelogram is very easy. It's just like a rectangle. Area equals base times height. The difference with the parallelogram is that the base is very clearly marked, right? The height right now is not visible. You have to draw in the height yourself. Give it a 90-degree angle. Alright, for our example for this one, we are going to draw a parallelogram. I'm going to say that the base of this parallelogram is 10. I'm going to say that this is, let's say, 8. And I'm going to say this is 45 degrees. Now, I know the base right now is 10. The height is missing. I'm going to sketch the height in. The height would go right here, 90-degree angle. And since this measure right here is 45, and this is 90, it means this also has to be 45, even if your picture is not drawn to scale. So I really do have a 45, 45, 90 triangle right here. I'm going to draw that triangle right here. So I have a hypotenuse of 8, and I need to figure out this length right here. This is my height. So I'm going to look at my reference triangle, 1, 1, root 2, and I know that the scale factor for this reference triangle, and you might have to do some math to figure this out, is 4 radical 2. That means that my height is going to be 4 radical 2. So my area is just base times height. The base is this again. Make sure that you use this entire base. My base is 10. My height is 4 radical 2. That means my area is 40 radical 2 units squared. Alright, moving on to our next shape, a rhombus. A rhombus is exactly like a parallelogram, except for all of the sides are congruent to each other. But again, I know that this is my base. My height you would have to draw in, right? You would have to draw in like that. So this is my height. So the area of a rhombus is base times height. There's also a second formula for rhombus. I'm actually going to draw another rhombus right here. And the second formula for a rhombus is actually, if you know the diagonals, you can draw 2 of them. So we could call this diagonal 1 and this one diagonal 2. The second formula would be area equals 1/2 times diagonal 1 times diagonal 2. And you can use either formula, it just depends what's given. Alright, we will do an example of a rhombus here. We'll say in this rhombus it has side lengths of 20. And we'll say that this measure right here is 60 degrees. So I know that the base is 20 because in a rhombus all the sides are the same, so this base is 20. And I know that this is 60. I need to find the height. I'll draw it in. If this side up here is 20, so is this. So the long side of my 30, 60, 90, I'm going to draw my reference triangle, 1, 2, root 3. The hypotenuse is 20, which means it's scaled by 10. My scale factor is 10, which means the height, I have to scale root 3 by 10, is 10 root 3. So the area of my rhombus is, I'm going to use base times height, is 20 is my base, times 10 root 3. That is 200 root 3. Oh, units squared. Units squared. Let me make sure that that's with my answer. Okay. We only have two shapes left. The next is a trapezoid, very common, and all trapezoids have two parallel bases. So I'm going to call this base, it actually doesn't matter. I'm going to call the bottom one base 1 and the top one base 2, and you can draw in the height anywhere, and that's my height. So the area formula for a trapezoid is 1/2 times, I'm going to put in parentheses base 1 plus base 2 because you have to add the bases first, and then I'm going to multiply that by the height. Another way you might see that written is like this: area equals base 1 plus base 2 times height divided by 2. Alright, so for an example here, we're just going to say, I'm actually going to draw a different kind of looking trapezoid. I'm going to draw parallel bases, and I'm going to have one side be a right angle, kind of looks like the trapezoid we did in the first one. I'll say this is 15, this is 10, and my height is, I don't know, 8. Alright, so the area would be 1/2 times base 1 plus base 2, so I have to do 10 plus 15, get my answer, multiply that by 8. Okay, so I have to do 1/2 times 10 plus 15 is 25 multiplied by 8. And I actually don't have a calculator on me, so I'm going to try to do this in an easier way. I'm going to take 1/2 of 8 to make this number easier to work with, and that's 4, and multiply it by 25, and I get 100 units squared. Alright, last up is a kite. A kite, if we draw the diagonals, it's really nice because they make right angles all through the middle. So the best thing about a kite is that if you forget the formula, you can just find the area of these triangles and add them up, which is really nice. But we're also going to learn the formula. The formula for the area is area equals 1/2 times diagonal 1 times diagonal 2, or you could write that area equals diagonal 1 times diagonal 2 divided by 2. Looks just like a rhombus, right? That is because a rhombus meets the definition of a kite. A rhombus can be considered a kite, but it has its own name, so we don't usually call it a kite. Alright, we're going to do our first example of a rhombus, or sorry, of a kite. I'm going to draw it like this. Alright, I know a kite has these two congruent and these two congruent. I'll draw in the diagonals. And we'll say that for this kite, you start with the segments. Let's say that this side is 10, this side is 8, and I'm going to say that this side right here is 2. Alright, so to find this height, or to find this area, I need 1/2 times diagonal 1 times diagonal 2. I have one of the diagonals because I know that this segment is 8 and this segment is 2. That is 10 total. So I actually know I have 1/2 times 10. I just need to find the second diagonal. The second diagonal, if you look here, this is an 8, this is a 10. That to me looks like a triple. Think about the 3, 4, 5 triple. If you multiply it by 2, you get 6, 8, 10. This missing side is 6. Now we need another property of kites to help us here, and that's that the smaller diagonal, the wing-to-wing diagonal, is cut in half. So if this side is 6, so is this side over here. And that means that this diagonal is 6 plus 6, which is 12. So the area of this kite is 1/2 times 10 times 12, that's 120, 60 units squared. Alright, that's it for the area formulas. The bottom of the page has some very helpful resources for you. It has the reference triangles listed. Remember, you need to memorize this from our last unit. It also has some triples listed.